Okay, today we're going to be going over the M96, M97 Porsche specialty toolkit. And this is a faultless toolkit that has been designed and manufactured as a joint effort between Flat Six Innovations and LN Engineering. Over the years of Flat Six Innovations building engines, we've had to make a lot of our own tools. And during a lot of our classes offered by the Knowledge Group, as you can see here, we've created a lot of tools that help make our job better and help make the job of our class attendees better as well. So I want to start off by bringing your attention to the first tool. This is a flywheel or crankshaft holding tool, if you will. And this is a heavy grade piece of steel that is designed to bolt onto the crankshaft and hold it during the torquing procedure of the crankshaft pulley. And this is if you did not have the flywheel fitted and could not use one of our flywheel locks that's sold in the flywheel locking kit. And you can see that video in another unboxing as well. So this tool bolts to the crankshaft here, bolts to one of the bell housing bolts here, and then it holds the crankshaft firmly. And this is a great tool to make sure you don't damage the crankcase by using a crank pin lock in the front boss of the crankcase that's not strong enough to hold the crankshaft during the crankshaft pulley torquing procedure. Okay, moving right along here, there is no factory tool that allows you to properly set the end play or crankshaft end float of an M96 or M97 engine, and this tool does that job. So basically this is able to thread into the crankshaft carrier, and then the dial indicator that you see here is fitted to it. The thumb screw is then tightened, and this is of course done on the crankshaft carrier. And then since this attaches to the crankshaft carrier, and this is actually able to measure the movement of the crankshaft, it will tell you what the end play is. This is a very critical tool for the proper end play adjustment and setting of the M96 or M97 engine. Again, this was not offered by the factory. Okay, and then here, this is actually the handle for our crankshaft position or crankshaft centering tool. Now, this is a tool that was offered by Porsche in the beginning days of the M96 engine, but then they stopped offering it. We've made our own version of it that's a little bit tighter tolerances. It has things the way we want it to be as far as crankshaft centering. So the way this tool is designed is the outer diameter goes into the inside diameter of where the rear main seal would go as a precision fit. The inside diameter here goes over the outside diameter of the crankshaft. So this tool is a no-go or go gauge. So a go or no-go gauge, either way. So if this tool will fit into an M96 or M97 engine and basically butt this portion up against the crankshaft, then that particular engine does not have a centering problem with the crankshaft and the rear main seal. If it fails that test and it literally won't go, in that case, the crankcase has a problem as well as the crankshaft carrier, and you must address that before moving on with an IMS retrofit procedure, a repair procedure, or a rebuild, or as we call it here at Flat Six Innovations, a reconstruction. So this is a great tool to use during pre-qualification of a job like an IMS retrofit. And this recreation of this tool is a very high quality piece with great precision dimensions. Here is another tool that was never offered by the factory, and this is a crankshaft seal installer for the front of the crankshaft. So the crank pulley bolt goes into this location, and you simply tighten down on the crank pulley bolt, and this will install the front main seal for you very squarely. Without this tool, you've got to do this with a hammer, and it's not a pretty sight. So this particular tool is a high quality precision piece that's made to squarely fit the front crankshaft seal into the crankcase, and so it'll have proper engagement with the outer diameter of the crankshaft to seal properly. Our next specialty tool here is one that I developed very early on at Flat Six Innovations for assembly, And the reason why is during assembly, the intermediate shaft kind of flops around in the crankcase with nothing to hold it in place. So this tool is made to have the outer diameter fit fairly loosely in the crankcase, and then the inner diameter to hold the intermediate shaft. Now this is on the end of the engine where the front console or the oil pump is located. This is opposite of the IMS bearing. So until you get the front console installed, literally the intermediate shaft has no support on the front side of the engine. So this tool is designed to give you support there. So a little bit of light lubrication on the inside of this, slide it into the crankcase, and it does a very good job of keeping the intermediate shaft from kind of beating the crankcase up during installation of other components until the front console is fitted. These two tools work together, and basically these are made of high-grade Delrin plastic, and they are designed to pass two of the original head bolts through them and hold the crankshaft carrier into place against the bank one crankcase half. So these particular tools were a factory item that are no longer made, and they aid in the assembly of the engine until you get the second half or bank two of the crankcase installed. So these tools keep the deck from being damaged, and they allow you to use two head bolts to retain the crankshaft carrier on its forwardmost end. And then last but not least, we have another tool here that is used for precision engine building, and we fit the dial indicator to it. It also has a thumb screw that holds that in place. And what this is designed to do is it allows you to measure the rock of the piston in the cylinder as well as measure deck height. So this particular tool is offset to one side. This is so you can put it on the cylinder at both 3 and 9 o'clock and check for your total deck height. Then you can move it to 12 and 6, roll the piston to top dead center, and you can measure the deflection or the rock of the piston when it goes to TDC. The reason you want to do this is to make sure you're not going to have any problems on higher compression engines where the pistons want to contact the cylinder heads at piston changeover when the piston starts going from one direction to the other. So this is another tool that we developed here at Flat 6 Innovations for precision engine building. So that being said, that will conclude this tour of the specialty toolkit for the M96 and M97. These are available from LN Engineering.